Early on when my research wasn't going that well and I was having trouble, people would be like, well, she's in a band. But then when my research started going well and I started publishing, they'd be like, wow, and she's in a band.
1, 2, 3, 4!
People think that you have to be one-dimensional to be a scientist, but actually your science gets better when you stimulate your creativity, your curiosity, all of that. So to me, actually, doing music helps me be a better scientist. I'm Pardis Sabeti. I'm a geneticist, and I'm a National Geographic emerging explorer. I use math to dissect the genomes of viruses, to decode them and understand how they evolve, how they spread, and ultimately how to prevent infectious disease and prevent outbreaks. So, I was born in Tehran, Iran. I came here when I was just a little girl, and the middle school me was just a little girl who loved math so much. I just loved the logic and the puzzles, and just as soon as I kind of really got into it, I never stopped. Math is it's a powerful tool to mine vast amounts of data. And genomics is just thousands, millions, billions of letters that you're trying to decode, decipher, using math, using computers. So that's what I do, and that's what I love. So a virus is a microscopic thing that can infect us and can cause a lot of harm, can make us very sick. And I study all sorts of viruses, from the common flu to Ebola. Ebola is a very deadly virus. It can have really high mortality rates, and it can spread really quickly. In kind of these worst case outbreaks, it can be 80%, which is why we were really worried about it. An outbreak is an infectious disease that's gotten out of control. Think of it like a wildfire. And you never really know where one will start, but you need to detect it. And you need to contain it before it gets out of control. That's what my work does for infectious disease, for outbreaks. During the 2014 outbreak of Ebola in West Africa, we essentially, when a patient's infected, their blood sample is taken for diagnosis. We're able to take that sample, deactivate the virus within it, and ship it to the United States, where we were able to prepare them and put them on sequencing machines and read out their genomes. So once we sequence a virus's genome, it might look something like this. This is actually Ebola's genome sequence, and there's clues in here. And we can use math and computation to start to decipher those clues, learn about the virus's history and how it's changing. All of this is arming us towards better detection, surveillance, prevention, really to be able to put out that wildfire. As somebody who studies infectious diseases, we're most successful when nothing happens, right? We are trying to stop outbreaks from ever occurring. And so we're most successful at that point, when we put out the sparks and you never hear about it. But that's an exciting challenge. So, one of the tools that we've created is an outbreak simulation that's spread over Bluetooth from phone to phone for middle schoolers to get to experience what an outbreak might be like, but before a real life event. So, we created this tool to be able to educate and, have outreach to students, but really we learned as much from them as anything else. Their participation taught us about how people respond to outbreaks, and their ingenuity, their thought process during the outbreak taught us so much. I love working in outbreaks because it requires cooperation. It requires people working together, collaborating, and that's how you win. And it's sort of the way I like to think about the world. I'm in a band. I'm not a singer-songwriter. I like being part of a collective. It's where the best things come together.